So we're going to have to talk about quickly how we see before you go on and do some of these stations. So the main thing of what you need to know is how do we see normally, and then we're going to see how you problems that can occur that affects your seeing, and then finally how do we fix them. So those are the three things: explain normally, problems that can occur, and how you fix them. So just generally how we see. So what happens is we see something. Light bounces off of it, so light hits the stop sign and bounces off of it, comes through the cornea, gets bent more by the lens, and it focuses it on the retina, the back of the eye. And it's actually flipped upside down, and then our brain flips it back right side up. But this lens right here does most of the focusing and the bending. So that's how light is refracted, and again, it's the retina that's then going to send it up the optic nerve to the brain, specifically the occipital lobe. So, I'm showing you some unhealthy eyes quickly just so you understand where that has to be refracted so you understand the next part. So the light has to hit exactly right on the back of that retina. Because if it doesn't, then it will be out of focus. Alright, so you probably heard of astigmatism or nearsightedness or farsightedness. That's what those words mean. We'll talk about them later. And when you have any of those vision problems, you need to get glasses because everything's all blurry. Well, the reason why is because you see the astigmatism. It's kind of hard to see here, but it's hitting multiple parts of the eye there. This one's too far in front of the eye, and this one, the image is being focused too far behind the eye. So what we would see is blurred vision, and that's what glasses come in, and we'll talk about this later on too. Glasses come on and put it right where it's supposed to go. So now, how does our eye do that? Well, you can look, most people, even with glasses, you can look far away and then near, and you can go back and forth really quickly and be able to read something far away and then close. So what happens is these muscles here, these ciliary muscles on the eye, they can pull up or push down to squeeze that eye. See how it's long and then fat there? All right, so the eyes can actually change shape, and it changes the way the light bends. So quickly, here's a little animation here. So if it's a far away object, it squeezes together long, and then the rays will get closer to a point. And then if it's a close object, it will get fatter, but it will bring the point to the same spot on the retina. It's because a little bit of physics there of how light rays work, but we're not going to worry about that. The main goal is this is called accommodation. So this is the second piece that you need. And what this is just the change of the lens to see close and far away. Now, if you notice, some of your parents might take the phone or the menu or something and move it back and forth in front of their face until they can get it. The problem is, as you get older, your lens gets less flexible when you're older. So therefore, it doesn't have as much bend and it's harder to focus. That's also why you have to wear bifocals, because you start getting myopia and hyperopia because that lens starts to go, so you can't see far or near. Alright, combination, change the lens to see far and near. Alright, so that's a combination. Then the last piece is color and peripheral vision. So the last thing of normal is obviously one, that's how come we focus the light in the image. And then we can see colors, and we can also see shadows in our peripheral vision, which is the sides when you're just kind of looking ahead and you see something out the corner of your eye. All right, so what this vision is it comes and it focuses. When it hits the back of the eye, it actually triggers different specific rods and cones. And these are fancy dendrites that then send signals along. This would be the optic nerve here. All right, rods are for black and white and light. They take in a lot of light there. And this is for color, cone for color. And you notice it's the primary colors, blue, red, and green. All right, so rods are for color. So if you're colorblind, these rods are messed up. And then black and white is for light and just black and white, the rods. Now, what that picture wasn't showing you is that generally you're going to focus more on this little thing called fovea, and that's where most of the cones are situated. So when you're focusing on something, you'll definitely be able to see the details and the colors. All right, but when it's out of focus, you might not see much of that. So like when somebody runs past you in your peripheral vision, you see their shadow, but you don't really pick up much detail or much color. And that's the reason why is because you're mainly using that light's coming off from the side. It's hitting this peripheral vision, and that's mainly rods, which are just picking up movement and light and just general things. Whereas the cones are generally right in that concentrated part. All right, so that is mainly how we see. That's how we refract light. It needs to be focused back here on that retina. And our lens can change to focus it and call accommodation, and then we have our colors of light.